And it's been an exciting couple days for space weather. Welcome to the Daily Space Weather Show. I'm your host, Dan, a.k.a. Smash-A-Mash, coming at you once again from the Smash News Network, least busted name in news. Thanks for tuning in. Congratulations on realizing the channel exists. It's only the world's most comprehensive daily space weather show and most detailed solar imagery you'll find in the known universe. These are 24-hour videos of the closest star, El Sol, the local yellow dwarf, Helios, whatever you'd like to call it. And that's 171 plus 211 angstroms. The 211 is the 60-minute running difference imagery. We've had a number of X-class flares. 2 in the past 36 hours. It's from Sunspot 3590, which is up to the northeast of our Earth scale in that imagery. And we'll show you some more solar activity here in just a moment. First, let's take a brief look at planet Earth, see what's going on in terms of volcanoes and earthquakes. So, Ibu is erupting. Also Semeru, Merapi, Dacono. And by the way, we don't show this because we think space weather causes volcanoes. There's just demand in the market of this type of nature video that people want to see volcano and earthquake coverage. So there you go. Popocatépetl also erupting in central Mexico, Sancho Guido and Fuego in Guatemala, Revenador, and Sabancaya. All erupting. And let's move on to earthquakes. So here are the past 90 days. As the 7 magnitude earthquake drought continues, guess what happens at the end of 7 magnitude earthquake droughts? Large earthquakes. So we've got a huge risk for the western portion of North America, folks. Check it out. These could be foreshocks once again. Is the big one coming to the western plate boundary of the North American plate? Let us know in the comments what you think. Foreshocks are the way to forecast earthquakes in reality, which is what this channel is somewhat fanatical about. Yeah, we're fanatical about things like facts and the truth. So, here comes some facts about the current shaken, and quite a lot of shaken there, especially on the eastern Pacific Rim. So a 5.1 at Indonesia at nearly 600 kilometers estimated depth, a 5.1 at Fiji, a 5.4 at Papua New Guinea. That was also at depth. Philippines had a 5.0. That was nearly 72 kilometers estimated depth. So there you go. A series of quakes, including several on the western coast of the U.S. Also, Kuril Islands had a 5.1 there south of Kamchatka. So that's what's going on for earthquakes. And before we get to more stellar stats, there are the past 24 hours in. Now we're looking at 304 angstroms plus 171 60-minute running difference. All eyes on Sunspot 3590 in your upper left. It remains a serious threat for X-class solar flares. Also, we've got a series of coronal mass ejections that are, guess what, folks? At least one is headed this way. So it could cause a major geomagnetic storm. We'll get to it. And we'll get to things like coronal holes and so forth here in a minute as well. So the 10.7 centimeter radial flux is now at, I don't know. I don't know what it's at. And just so you know, folks, my shirt is all full of space. Yeah, it's all full of space. So don't worry, folks. I'm not a monolith. Everything's fine now, Dave. So yeah, the 10.7 centimeter radial flux, for those of you not aware, is the most proportional data set we have to sunspot number. There you can see it depicted by this black line for the past year from Solon.info. Red line is the sunspot number. Black line is the 10.7 centimeter radial flux. And it is currently at 173. So a little uptick since yesterday. 173 is a new radial flux number. You can expect to see higher highs and higher lows for the next about 8 months. So that's because we're getting closer and closer to solar maximum. So you can expect to see, again, higher highs and higher lows in both the red line and the black line. See our channel forecasts, because understanding the data and the correlation and the known physics is how you forecast a thing. Otherwise, you don't forecast, and that's how it works. I can't believe I have to say that. Yeah, we're able to forecast stuff by understanding the correlation between things like facts. So I know it's so controversial, right? Anyway, Space Weather Enthusiast dashboard here, not forecasting any geomagnetic storms. All right. I think that's going to update soon, but we'll see what happens by tomorrow, as I believe there is a CME launched today that is earthly directed. We'll get to it. First, the past 4 hours of Earth's magnetic moment from space. That's our Geospace Magnetosphere movie, which is a model created by the Space Weather Modeling Framework. It uses a whole series of different variables, such as solar wind density, magnetic field orientation, electron flux, and all kinds of other features. So that's the past 4 hours of Earth's magnetic moment from space. Here's Earth's magnetic moment from the ground. We show at least 4 hours daily on the channel just to sort of show you where the telluric currents are likely when we do have activity happening. So yeah, there is a geomagnetic storm on the way, folks. One of those CMEs is somewhat earthly directed. So anyway, and yesterday we forecasted an X-class solar flare, so that's always nice. Next, the KP index is at 1.67, so not very active in terms of geomagnetic activity at the moment. 1.67 is the KP index, an average of global geomagnetism. Next, we'll look at some solar wind data. What's going on with ACE? There you go. ACE looking pretty diffuse at about 2 protons per cubic centimeter for the solar wind density. Solar wind velocity here just under 350 kilometers per second. The Discover showing quite a bit faster and quite a bit denser solar wind there. So solar wind density there about 6 protons per cubic centimeter. Solar wind velocity here nearly 500 kilometers per second. Looks like a coronal hole high-speed stream has now taken over. So we're seeing multiple solar wind regimes there, and now we're seeing a solid signal. Looks like coronal hole high-speed stream. Who knows how long that one will last? It wasn't really forecasted. So that's what's going on. The GOES magnetometers are next, and they're pretty smooth. No real surprise there to regular viewers of our channel, as there have not really been any space weather events of note. It's been very mild, as the sun has been plasma miser. Next, we'll show the top view ecliptic plane field plot to show the magnetic sectors of the solar system. So there you go. There is the current magnetic sector is south pole orientation, and we can expect to stay there for a couple of days, assuming nothing rapidly changes. Now, keep in mind there are some new sunspots rising, and the magnetic environment can change with basically no warning. So, but at the moment, things are looking pretty stable in the east. We've got a number, at least 3 new sunspots just rising, so you can expect a big uptick in the sunspot number coming tomorrow. There's another forecast for you. Next is our line of sight field plot. And the photosphere magnetism depicted here in grayscale, and then you've got the solar B field in blue, polar fields in red and green for south and north respectively. Next, coronal hole line of sight plot. And we've got both north and south pole oriented coronal holes there on the Earth side of the disk. There is the SDO 211 angstroms wavelength, which is just splentacular at showing coronal holes. So, of course, those coronal holes around just south of the equator there, those are becoming more and more well-defined as they rotate toward the Earth-facing zone. Keep in mind, folks, that's because the solar corona, the sun's atmosphere, is extremely bumpy. So there you can see, when you look at the edge, you can see huge bumps there that are hundreds of thousands of kilometers in height. And that's part of the reason why coronal holes become more well-defined as they face the Earth, because you're looking down into a very three-dimensional object there. I know there's not that much contrast, but you can see it around the edges of the solar limb and at the poles. Anyway, moving on to sunspots. And we've got a tiny uptick in sunspot number today, but you can expect it to go up by like 50, 60, 70 sunspots by tomorrow, as we've got 3 groups rising, and we may have some growth in sunspot 3590 as well. We'll get to it here in a minute. First, our flare probability monitor and scoreboard. Oh, and the current sunspot number is still only at about 53. 53 sunspots at the moment. Again, expect a precipitous uptick by tomorrow as multiple new active regions are rising. By the way, Let's pause for station identification. Thanks for tuning in to the Smash News Network least busted name in news. Why are we least busted? Because we don't cite nonsense on the channel. We are interested in advancing the science, namely the way heliophysics relates to cosmology. And so we're throwing in these videos along with the meteorology segments as a value-added service. So there you go, flare probability monitor. Likelihood of an X-class solar flare is greater than not. Look at that, an X-class flare more likely than an M-class flare with the current magnetic configuration, which is very complex and very volatile. So let's take a look at sunspots. And of course, 3590 will remain the story, as it harbors the kind of magnetic fields that are likely to produce major solar flares. That's how we forecasted one on yesterday's video. Here are the magnetic fields. And we are seeing some field migration happening there. So plasma around sunspot 3590 is looking quite unstable. Here's an extreme close-up. Pardon the fact that it's truncated off the left side of the screen there, folks. Sometimes when you make a video on HelioViewer, it just is not in the place where you actually positioned it. So that is an unrecoverable error, but still some pretty good data there. You can see the migration of that leading North Pole umbra shown there in white. And you can see some South Pole umbrae there very close to the main leading umbra. So again, quite volatile is sunspot 3590. The likelihood of X-class solar flares is very high, about as high as it ever gets, folks. So there's an extreme close-up of sunspot AR 3590. And it's a little bit larger than Earth there in terms of its diameter. Of course, sunspots are almost like depressions in the solar surface. The area between the umbra and the penumbra, which is the penumbra is the gray area in between the black and whiter portion. That is like several thousand kilometers of altitude difference there. As sunspots are three-dimensional features. They're like depressions in the sun's photosphere. So a great view once again of sunspot 3590. And let's move on to look at something a little bit more relaxed. Shall we? Yes, we shall. Actually, no. We shall not. We shall move right along to solar energetic particles and flares. Goes proton flux here, returning to flatline levels. And there, we just had another X-class event. So there you go, 3 X-class events in just about 24 hours. Another X-class solar flare happening while we create the video. So I like it. What do you think? 2 days in a row with an X-class solar flare while we produce. Not half bad. Let's take a look at some fantastic imagery from SDO. Once again, sunspot 3590 not failing to impress. Just like our channel's not failing to forecast. So, of course, the way the channel got started, folks, was doing weather reports. Of course, I realized years and years ago that it's way too easy to forecast Earth's weather. If you're unable to forecast your own weather, to extremely precise forecasts in your local location, well, you're not looking at the right data or you don't understand the variables, because forecasting Earth weather is far too easy, especially on like a 24-hour basis. Beyond 3 days, nobody's forecasting Earth's weather. But if you understand the physics, you can tweak any forecast to be spot on by understanding the variables. Anyway, decided I needed some additional challenges, so here we are. And you know what? It looks like that last X-class flare. Did it come from that sunspot rising behind the limb there, folks? It may have. I think it did. No, maybe not. All right, I don't know. But there is another active region rising, so we have a massive solar flare watch. We've got an X-class solar flare watch both in sunspot 3590 and this new active region rising. That's certainly producing some large flares. So the likelihood of large flares has gone up. And of course, the likelihood of space weather, well, we'll get to the CMEs here in a minute. First, we'll take a look at a star chart. This is one we'll show you something more relaxed. This is what's going on overhead where we are located in Lehigh Valley, Pennsylvania. So there you go. We've got a nearly full moon. I think tonight is actually full moon. Well, that shouldn't be. It seems too early for that to be rising. Hold on. Is that right? Well, we'll show you in a minute. So, but there you go. If you're viewing the early evening sky, you might see Jupiter high on the ecliptic. The moon, or if you go in between them, making a triangle to the southeast, you might see the brightest star visible, at least in terms of apparent magnitude, the dog star, Sirius. Next, our solar system forecast, brought to you by theplanetstoday.com and, of course, the Smash News Network, least busted name in news. No official affiliation there, but theplanetstoday.com does offer a great model to do solar system forecasts. So here's where heavenly bodies are today. Here's where things will be in 1 week on Leap Year Day, where we'll be wishing Mr. Chuck Canfield a happy birthday. Moving right along to our astronomy photo of the day. It's of some galaxies, and I'm not that excited about it, but there you go. A couple of galaxies, and I don't know what the hubbub is all about, but it's M106, part of the Messier catalog. Messier entry number 106. Anyway, let's get to CMEs. Those are kind of important. So here are today's CMEs, and we anticipate one of these being earthly directed. So let's see if we have it there. It's to quote Red Letter Media, it's let's just move on. Pretty sure there is Earth-directed ejecta in there. Let's get a little closer here and see if we can get a bead on it. You've got Mercury there on the LASCO C3. And let's wait until we see that popping off. It was later in the day, and we might have some missing data there. So that's unfortunate. Let's move on to Stereo A with its difference imagery. And that's also missing data, it looks like. Oh, now wait. It's almost up to date. Let's see if our custom coronagraphs are any better. Here's LASCO C3, NC2, and the SDO 304 angstroms wavelength all together. And let's get a little closer here. So, of course, the usual suspect is going to be Sunspot 3590, but we don't want to misidentify ejecta coming from someplace else. So, let's have a moment of zen, folks. All right, concentrate. Everybody concentrate. We're going to move in one step closer here. Yeah, there is some missing data at an unopportune time right there. But I suspect there is some rather minor ejecta coming out of Sunspot 3590. So that's my best guess. Again, there's some missing data there. It is not very helpful. We'll zoom in one more step and add the 193 angstroms running difference imagery. And yeah, that's not a real definitive earthly directed CME, but there is some ejecta moving around here. You can see a filament definitely playing around, and we don't really see it splashing back down. So basically, through a process of deductive reasoning, we think there's another CME headed this way. Expect that one to arrive sometime late in the day on the 23rd. Not the 23rd, the 25th. So late in the day on the 25th, CME expected. Don't expect a major geomagnetic storm. You might see as much as a KP6. That is based on, of course, magnetic field orientation, plasma density, plasma speed, and magnetic field strength. Those are sort of the four most important variables there. Magnetic field strength, magnetic field density, plasma density, and plasma speed. So that's why we watch those things mainly on the solar wind. These are 24-hour videos. Let's get one step closer here. So it's There is a filament you'll see right down here that looks like it ejected, and I believe part of that is headed toward Earth. Now keep in mind, when it's that close to the center of the solar disk, from our perspective, it's very likely to have Earth-directed components. So fairly diffuse, though. Again, we don't expect it to be a major impact. Shouldn't be more than a KP6 if it even creates a geomagnetic storm at all. Anyway, here's an extreme close-up. And just the equatorial zoom there. Just spectacular imagery. 171 plus 304 angstroms. The 171 is the 60-minute running difference imagery. Not half bad. Don't mind us. It's just the most detailed solar imagery you'll find in the known universe. Pushing 6 years on this. And here come some close-ups. Dag! Sunspot 3590 is definitely one for the history books. Pretty berserk levels of activity, and you can expect them to only increase for about 8 months, which means you can expect about 16 months with levels of solar activity what we're seeing now. So lots of space weather to cover, folks. It's going to be an exciting 16 months. We're excited, and we hope you are too. Anyway, let's move on to solar filaments, as we don't want the video to be too lengthy. Here come solar filaments from Cerro Tololo, Chile. So one of them blasted off over here. I don't think that one's earthly directed. But the one we're talking about came from just southwest of Sunspot 3590. You may see it jump off in the colored imagery. It's kind of right in here. Yeah. But not a major earthly directed CME. Let's move on before we get to bonus features. The last few hours of the GO 16 SUVI. And let's just go back to our X-ray flux here for a brief moment. So peak flux of the most recent flare was at 2333. So that's a little while ago. 2333, right? What the heck? How could that be? 20... What? What? Oh, 2233. All right. That makes more sense. Why do we not have that data? 2233. We got old data on the GO 16? Are you kidding me? Look at that. Old data on the GO 16. That is... I don't think we've ever seen that before. Anyway, moving right along to our charging hazards map. So this is our bonus features segment where we close out space weather with some bonus features like charging hazards. We ain't got none. The GO's electron flux is next. And it is still at very low levels as it goes on for months here since December, seeing essentially an electron shortage at the F layer of the ionosphere where it's measured by the GO 16 and GO's 18. There's the forecast model. Check it out. NOAA forecasted it way lower than it is. I don't know if that was a CME impact that never showed up or what, but much higher than NOAA's forecast. The next forecast is for it to be at flatline levels. So, okay. No arguments. Next, the layer where it's measured, the F layer of the ionosphere. Here comes the vibrational frequency of it. It's courtesy of Australian Government Bureau Meteorology, and there ain't nothing going on up there, folks. It is calm in the ionosphere. No recent space weather showing up to shake things up, at least in terms of solar plasma. I mean, of course, the D layer of the ionosphere has been getting attenuated by solar flare activity. Of course, we just had a major radio blackout as a result of an X-class solar flare. So anyway, there's the anomaly in megahertz from a 30-day median, and again, things are not very exciting when it comes to space weather, at least in terms of the particle forcing effects on the ionosphere. Things are pretty calm. We'll also show the WHAM, the whole atmosphere model. So there you have it. Total electron content and anomaly on the left, maximum usable frequency and anomaly on the right. And we're closing out space weather with the latest close-ups of the closest star. So this sunspot 3590, is quite magnetically complex. Look at the Beta Gamma Delta class sunspot. It's a classic Beta Gamma Delta class sunspot. And expect the flaring to continue, folks. It's become more magnetically complex since yesterday. Also, we have a number of new active rising regions on that eastern limb. So if you thought the sun was shutting down, sorry to rain on your parade, but that is a parade that should be rained on, because this is an average to above average solar cycle. So those are some facts for you. And terribly sorry if you were offended by those. Is that a new sunspot up there? I think that's a new sunspot. But guess what? I'm not even concerned about it, because I'm not spooked of an active sun or an inactive sun. I don't find either thing spooky. Did you know that 11-year solar cycles go back probably millions of years, but at least over 1,000 years? So all of these insane forecasts that, the sun's going to suddenly shut down, is just an idiotic and ridiculous, unfounded, not even a hypothesis. It's just nothing but pure conjecture. People just guess about a thing, and then they go, it must be. I mean, it's bizarre. It's just bizarre. Anyway, let's show the full disk rock back and then move on, because, again, we don't want the video to be too lengthy. So there's the full disk rock back. Multiple new sunspots, at least three new sunspot groups, maybe even 4 rising in the east. Expect an uptick in the sunspot number tomorrow, and a big uptick in the sunspot number in the next 24 hours. Next, look at the Pacific Ocean. Here's the surface wind scenario. I zoomed in on this area here because this is interesting. We've got a high pressure zone right here, known as an anticyclone. You'll see this clockwise rotation in the northern hemisphere, and then 2 lows. One of them is kind of large, and one of them is kind of strong. So there's a fine example there of a large low that's not that powerful, and a small low that is quite powerful, with an anticyclone in between them. Anticyclones are high pressure zones that rotate clockwise in the northern hemisphere. And let's move on to the rest of our meteorology segment. So there are the surface winds of the east. There are the jet streams of the central world shown here. Remember, folks, never sneak up on a dragon in its own lair. You will fail to surprise it, and it might be a little bit cross with you. Anyway, speaking of cross winds, there are the surface winds of the central world. Heavy onshore wind there at Spain and Portugal. Perhaps some big wave surfing happening at Portugal, the world's current record holder for the largest wave ever surfed. Next, surface winds of the west and the jet streams of this side of the planet. A huge kink in the jet stream there, bringing warm air up into eastern Canada. Next, clouds and fog for the Americas. That is our shortwave radiation map, depicted by the GOES Interactive Weather Satellite Suite. Next, we're going to show, what should we show on windy.com? Does anybody have a request? I guess it's not really going to matter because this video is not streamed live, but let's bring up, how about waves? Let's check out waves. There you go, and check it out. Massive waves up there in the North Atlantic, 40-footers. The world's stormiest seas are southeast of Greenland. Next, our weather.gov map, and things are pretty calm here in the U.S. Finally, the weather warnings are cooling down. Not the Earth, just the weather warnings. But, there you go. There's the key. There are the weather warnings. If your county is lit, click your county on the map at weather.gov, the National Weather Service homepage. And here comes some forecasts. The GFS 72-hour pressure and precipitations first. Beware Washington. Some heavy precipitation is on the way once again. Straight out of Vancouver, straight into the Olympic Peninsula. Yowzers, heavy snow and rain coming. Next, accumulated precipitation forecast in inches. 72-hour GFS model once again. 72-hour GFS model for a snow depth change in inches. Looks like most of that snow is going to actually be, most of that precipitation in Washington looks like it's going to actually be rain there. But heavy precipitation coming. And last but not least, temperature anomaly forecast in degrees Celsius. Same model, 72-hour GFS. So yeah, that's what's going on. Those are what's called accurate forecasts. And we'll close out with lightning. There's our real-time lightning map from blitzachtung.org. And let's zoom in. What do we got? We've got some thunderstorm activity there in places like Arkansas, Missouri, and Kentucky. Or do we? Please connect. By the way, we have a lightning-fast Verizon Fios internet connection with like 300 megabyte upload and download speed, so that is not caused by our internet connection. It is hardwired, and it is shockingly fast. So yeah, we got a little thunderstorm activity there. It looks like nothing too major. Now some pretty significant thunderstorms there. Some in Missouri there, some in Arkansas. Anyway, you saw the map. A picture says 1,000 words. And a grifter gathers 1,000 turds. So there is the Doppler radar depicting vertical motion in the air column. So we've got a bunch of precipitation here moving into the mid-Atlantic states. Here is the clouds and fog view from the NASA GOES Interactive Weather Satellite Suite, the shortwave radiation map, and there is the water vapor map. You can see this huge dip in the jet stream. The jet stream's coming down like this and making this massive bend. Again, bringing warm air to places like Newfoundland, who I'm sure can use it, as that is a very inhospitable place. A giant rock off the Canadian coast. Anyway, here's your recap U.S. Doppler radar that depicts ground-based systems' vertical motion in the air column. It shows things like precipitation, but don't get fixated on it because it can be very deceptive, especially when you have pressure gradients, which we do. So here's the clouds and fog map. Yeah, you can view clouds and fog at nighttime. Use shortwave radiation at 3.9 micrometers, part of the infrared spectra. Part of the infrared spectrum, I should say. And there is the water vapor map. So not real huge pressure gradients here, but we do have this moisture, this flow of moisture moving this way. We've got some dry mass of air down here, which is a relative high compared to the surrounding area. And yeah, that's the jet stream is in control of that, and I'm in control of ending this video because it's time to get it uploaded and onto your screen. So thanks for tuning in, everybody. Congratulations on realizing the Smash News Network least busted name in news exists. If you are adverse to the controversy of facts, then we feel terribly sorry for you. But I get in trouble for telling the truth. So enjoy that. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And until next time, may that solar wind be at your back.